Now that we've had the opportunity to refresh our memories on how we can tell a transformation, I want to go ahead and get started with practicing some of these transformations. I've taken the liberty of putting the parent function f of x equal to the absolute value of x graph already onto the coordinate grid, and we can go ahead and fill in the table of 2, 1, 0, 1, 2 to match what is already on the graph. Now if we take a look at our g of x, or our new function f of x, we really should change that. We'll make that into g of x. So that way we remember that they're different. We can look at, we have 3 times the absolute value of x. So I see here that this 3 is on the outside, which tells me that it is vertical. And it is out front, and it is a multiplier, and it is bigger than 1, so that means that it is a vertical stretch. And my factor is a factor of 3. Now because it is vertical, and I don't have any horizontal transformations, when I write my rule, x stays x, but because it is a vertical stretch times 3, we're going to make it 3y. So that means that all of our x values will stay the same. So I'm going to rewrite those as -2, -1, 0, 1, 2. And it says according to our rule that all of our y's will be tripled. So 2 times 3 is 6, 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3, and 2 times 3 is 6. So now we need to go ahead and graph those points. So I see -2, 6, -1, 3, 0, 0, 1, 3, and 2, 6. So then we can go ahead and graph our lines on our function. And we have a steeper V, which means vertically we stretched it, which makes it taller. So if we look at the domain, we see that our x values for our parent function we learned are all real numbers. And for the parent function, the range is that y is greater than or equal to 0. And I'm going to mark these as f of x, and then I'll do g of x in a different color. Now g of x, we have still, just because it stretches taller, it just takes a little longer to get out wider, which means it doesn't change anything, so it is still all real numbers. And our vertex is still at 0, 0, so that means that our range is still y is greater than or equal to 0. Let's try another example. And we have here now, same thing, I've graphed the parent function already. I see here, as I fill in my table, that I have 2 different transformations going on here. One of them is referenced by this negative sign, and the other one by this +4. So when I look at this, my +4 tells me that it's vertical because it's outside, and it is a shift because it is a +4, and that is going to be a vertical shift up 4. And then this negative sign is out front, so again that would be vertical, and because it is a negative sign, that is a vertical reflection. So looking at this once again, they're both vertical, so they don't affect the x at all, so I'll leave x as x. And the reflection tells me I'm going to take the x and make it the opposite, and then it's going up 4, so I'm going to add 4. So when I go ahead and do so, and I apologize, this should say, let me fix this. This should say y, not x. And then when I go ahead and fix this, x stays the same. So once again, -2, -1, 0, 1, 2. And it says we're going to make y the opposite and then add 4. So the opposite of 2 is -2 plus 4 is 2. And the opposite of 1 is -1 plus 4 is 3. The opposite of 0 is still 0 plus 4 is 4. Opposite of 1 is -1 plus 4 is 3. And opposite of 2 is -2 plus 4 is +2. So if I graph these, I'm still at -2, 2. And now I have -1, 3. And 0, 4. 1, 3. And 2, 2. Notice that my absolute value function has flipped over upside down. So when I take a look here, my original f of x had a domain of all real numbers, which we have already expressed, and a range of y is greater than or equal to 0. When I take care of the domain and range of the transformed function, the domain is still all real numbers, even though we flipped it upside down. However, my y's, because we go downward, are going to be less than or equal to 4, because 4 is where that vertex point is. Now, our next time is going to be talking about finding the absolute value function from the graph, which will be our next topic.